Are you an art lover? I've got something very, very special for you. Replace the ink in the pen with something as simple as sugar water. Use a lighter to heat the paper. The sugar breaks down to give you a black residue. This is known as caramelized sugar, the very same as the one in the caramel cake that you might have eaten. Whether you are an art lover or not, you will start loving chemistry now. Because what you just saw here was pure chemistry. It's nothing but magic. Chemistry in reality. Why is it important to learn chemistry? Because understanding chemistry helps you understand the world around you. Cooking is chemistry. Everything you can touch or taste or smell is a chemical. When you study chemistry, you can come to understand how the things work. When I use the word chemistry, most of you would conjure up an image of a scientist hunched over some esoteric lab equipment, rattling of even more esoteric names of chemicals and their properties. But chemistry is not just about that. The bigger picture of chemistry is that it is about every single thing around you, including us. Because chemistry is all-encompassing. It is a part of all of us. It is inbuilt in us. We are made of chemistry. As the building blocks of chemistry are elements, elements are what build each and everything that you see around you, including you. Chemistry gives us the explanation for everyday things, like why laundry detergents work better in hot water, or how baking soda works, or why all pain relievers work equally well on a headache. If you know some chemistry, you can make educated choices about everyday products that you use. One more interesting thing to note is that just like the English language is made up of 26 alphabets, everything around us, including us, is composed of the 118 odd elements. Isn't this just enthralling? To understand chemistry in a nutshell, you will need to understand about the all-elusive electrons. All atoms contain negative particles called electrons, which reside in different tiers or energy levels inside the atom. The levels are nested concentrically inside each other, and each level needs a certain number of electrons to fill itself and feel satisfied. In the innermost level, that number is 2. In other levels, it is usually 8. Elements normally have equal number of negative electrons and positive particles called protons, so that they are electrically neutral. Electrons, however, can be freely traded between atoms, and when atoms gain or lose electrons, they form charged atoms called ions. What's important to know is that atoms fill their inner or lower energy levels as full as possible with their own electrons before they can either shed, share, or steal electrons to secure the right number in the outermost level. Some elements share or trade electrons diplomatically, while others act very, very nasty. And that's half of chemistry in one sentence. Atoms that don't have enough electrons in the outer level will fight, barter, beg, make or break alliances, or do whatever they must to get the right number. Why I said half of chemistry is because the other half is composed of changes in the nucleus. That is, the number of protons or neutrons can change in certain situations, and when this happens, it causes a lot of energy to be created, like what happens in an atom bomb. Why is a lot of energy released? This is where Mr. Einstein's E equivalent to mc square comes into being, where mass is getting converted into energy. Anyway, for now, let's stick to the first part where mass is conserved and electrons are being shared. Let's look at different types of chemical reactions and how they are represented on paper. Actually, all chemical reactions that you see around you where electrons are involved can be broadly classified into 5 reactions, and that is what we will be learning through this session. The reactions are combination, decomposition, single displacement, double displacement, and reduction and oxidation reaction, commonly called the redox reaction.